Good morning, everybody, and welcome to another GoodWe SSA webinar. Today we'll be discussing the ET50 along with its partner, the STS, static transfer switch, and then the battery pairings that come with it from the GoodWe side, so the BAT50 and BAT100 series batteries. This is the third webinar that we're hosting this year, and like I've mentioned in one of the previous ones, all of these webinars will be fully recorded and then uploaded to our YouTube page for future reference. And we will continue this series throughout the year, just to give you guys a little bit more information on our products, what's coming up soon, and then obviously just to give you a bit more information outlay on any of our products that we have in the market. So without wasting too much of everybody's time, I'm going to jump straight into it. It won't be the full hour-long webinar that we've got scheduled, unless there are, of course, some questions in it that we ask. However, I'll try and make it as brief and understanding as possible, while still not leaving out any relevant information. Okay, so this is our three-phase high-voltage hybrid inverter. So this is our ET50. So ET stands for energy storage three-phase, and then the 50 kilowatt iteration of this unit is the unit that we'll be discussing today. So if you look on the right-hand side of this picture, you'll see there is a hybrid inverter at the top, and underneath that, the static transfer switch. When you look at this inverter and think of how the installation of this inverter works, is think of the hybrid inverter at the top as a grid-tied inverter with a DC battery port. And then if we need any AC switching done, we include the static transfer switch or STS box. So on the inverter itself, we do all the DC to AC converting. However, we do not do any AC switching. All the switching gets done through the static transfer switch. So our grid connection comes into the static transfer switch. We will then be able to distribute that power either to our backup loads or from our generator into our backup loads, or from the inverter through and into our backup loads. I'll explain it in a little bit more detail as we go through the presentation today. However, that's kind of the basic concept of our inverter, is that we've got a DC-AC converting hybrid inverter, and with the STS separate, we do all of our switching. So it is theoretically an on-grid inverter with a backup port, with a battery port, and then if we add the STS, we get a full hybrid solution. Have a look at the inverter itself. So these are just some of the dimensions of the ET50, the weight being around 65 kgs. So note the size of the physical inverter is a lot smaller. It does make things a bit easier for installation purposes due to its smaller size against the capacity of the inverter. This is just some of the parts and port numbers of the inverter itself. Most notably, you'll see port number 15. That is the AC output port. That is the only AC port on the inverter itself. And that's the port that we use if we're running this inverter as a grid-tied inverter for something like peak shaving or time of use application. We would use just that one port. If we connect it to an STS, we'll connect from port 15, the AC output port, into the STS, and the STS will then be able to distribute the power either into our backup loads or back into the grid if we are allowed to export. Please feel free to ask any questions in the Q&A section of the webinar, and I will go through all of them at the end and then just refer back to any of the slides if we need to. Have a look at the parameters of the ET50. So within the parameters of the ET50, we'll first look at the battery input data. I'm not going to go through every single piece of information in the data sheet. That is all available on our website via either the data sheet or the user manual. If we look at the battery input data on the ET50, you'll see it is a high voltage inverter, meaning you need to use high voltage batteries, with the maximum charge and discharge currents of the battery input port being 100 amps. We can continuously charge and discharge this inverter at 55 kilowatts, 5,500, 55,000 watts. Again, this is very much dependent on the batteries that we have installed. We're going to be installing batteries that can't discharge at 100 amps or can't discharge at 55 kilowatts. We're obviously not going to get that full amount out. One of the key features of all GoodWe inverters are these two things. So one being the percentage of usable PV energy that we get out of our inverters, and secondly, the MPPT operating voltage range of our inverters. These supersede a lot of other inverter manufacturers. However, this is just a key strength of the GoodWe inverters, and this is where we really come to shine. So on the ET50 inverter, we can add 75 kilowatts of PV or usable PV energy is what we can get through the inverter, meaning 75 kilowatts of PV is what we can load onto the inverter. 50 kilowatts of that can go towards your loads, 25 kilowatts of that can go towards your batteries at exactly the same time. In any iteration, so you can have 20 kilowatts of load and 50 kilowatts of PV charging towards your batteries to a maximum of 75 kilowatts. So it's 150% PV oversizing. Next is the startup voltage of our inverter. So the inverter startup voltage is 160 volts and 165 volts is where we start operating. Note this is a high voltage inverter, it's a 50 kilowatt three-phase inverter. So the operating voltage being as low as it is extremely competitive in the market and something that we definitely do pride ourselves in. This just means that we get extra PV power production during the day or in really bad weather conditions, early in the morning, later in the afternoon, something like that. If we look at it from a sales perspective or in a sales hat on, that 165 volts realistically, no, is not going to run your loads. However, it does start trickle charging towards your batteries. So if you get an extra, let's call it 10 minutes or 15 minutes a day of PV production, that PV production power that we get allows us then to charge your batteries within that extra 10 or 15 minutes over a 5-year or 10-year lifespan of the inverter or 10-year proposal that you're sending out to the customer. That total energy throughput that you're getting additionally for 10 minutes every day for the next 10 years makes a big difference. From an installation standpoint, we obviously want to try and get as close as we can to the nominal input voltage, so 620 volts. At 620 volts is where we get our maximum MPPT efficiency. However, we do run at a nominal power range between 400 volts and 850 volts. So it's just a quick look at the AC output data, grid data that we get. Just noting that the nominal power from the grid through the grid ports net is 50 kilowatts, which makes sense. This is a 50 kilowatt inverter. Your nominal output current at 72.5 amps with the maximum output current of 83.3 amps per phase. So nominal 50 kilowatts with a maximum of up to 55 kilowatts permanently. And then one of the next features of our inverter, if we look at the max output apparent power, it's 75 kVA, 75 kilowatts for up to 10 seconds is what we can handle for inductive load startups and things like that, or any overloading purposes. So how our inverters work when it comes to overloading is, yes, we are high frequency transformerless inverters. However, for overloading purposes, we use the built-in DC capacitor bank that's built into the inverters, meaning that if there is any inductive load startup or heavy load startup or anything that exceeds the 55 kilowatts, we can handle up to 75 kilowatts for 10 seconds. What's very nice about this, like I mentioned, it does get done through the DC capacitor bank inside the inverter, meaning that we don't have any additional pull or any additional power requirement from the battery which means we're not going to try and damage the battery in any way. We're not going to try and pull any additional power from the battery or anything like that. Battery is capped to a limit of 100 amps, 55 kilowatt discharge, which means if there is any additional power that needs to come out of the system, it gets done through the DC capacitor bank in the inverter. We're looking at generators, for example. If there's any inductive load startup or anything like that, we'll draw that additional power, the actual physical flywheel on the generator, or either stagger, slow down, or slightly reverse in order to handle that big inrush of current or inrush of power. If we're looking at a transformer-based inverter will do that through the physical copper coils or transformer that's built into the inverter. Our inverter, being a high-frequency transformerless inverter, does this through the DC capacitor bank built into the inverter itself. Just going back to that, often we get questioned about what happens if we have a load of 60 kilowatts, for example. Does it mean that we'll be able to overload the system for maybe 30 or 40 seconds as opposed to 10 seconds? Hardware-wise, yes, it will be able to handle it for a longer time because the DC capacitor bank will take a longer time to discharge. On the software side or on the firmware side of things, no, it is capped to a 10-second overload time to protect the inverter itself and obviously to protect the loads on the output side, to protect your cables as the installer running the system. Generally, you're going to spec the site to run at 55 kilowatts, for example. We don't want to have a very long sort of overload of anything higher than that to potentially risk damaging anything down the line with the physical installation. So the inverter will cap the system to any overload more than 55 kilowatts for 10 seconds. After that 10 seconds, it will restart the inverter or give you an overload error. We don't see this happening too often. On a 50 kilowatt inverter, the chances of having to exceed up to 75 kilowatts is very slim. Obviously, there are certain conditions where this isn't the case, when we've got bigger inductive load startups and that kind of thing, which we obviously are seeing now in the C&I space. And we're seeing that because of the amount of factories and that are not necessarily putting in hybrid solutions or hybrid systems for full-on backup application, but rather for peak shaving and time of use tariff setting changes and savings in that space. How can we get around the 75 kilowatt overload timing and that kind of thing? If we've got massive inductive load startups using a transformerless inverter or high frequency inverter, there's two different ways we can do it. The first one is obviously adding additional inverters to increase the amount of capacity that you've got on the inverters. Just to note, obviously I have 83.3 amps per phase, which means if we parallel the system and we increase the system physical size, we get more power output. That's quite self-explanatory, obviously. And then the second way of doing it with a transformerless high-frequency inverter would be using something like a VFD or VSD. By having a variable speed drive or frequency drive, it allows us to have a slower startup on these big inductive motors, and by doing that, we won't necessarily overload the system. If we're looking at cost comparison or that kind of thing, it does or it can work out to be a more cost-effective solution by using a VFD and a transformerless inverter versus using a transformer-based inverter. When you're using a transformer-based inverter, your DC-AC conversion efficiency does change because the transformer built into the inverter needs to also be sustained or it needs to be consumed within the power of the inverter itself. So again, it depends on the application, it depends on the site. When it comes to C&I, the recommendation is always go and log the site. Please do logging on the site. Make sure that you understand what the customer's power requirements are. Make sure you have a better understanding of what the system entails, how the system needs to be used, whether it's just for peak shaving, whether they've got a big generator that can sustain bigger loads, whether they've got all of their systems running when the backup needs to kick in, whether they've got a sequential startup on certain motors or something like that, VFDs, VSDs are installed. You know, there's a long list of things that we look at when it comes to C&I projects. However, please do reach out to anybody or any of the teams here at GoodWe, and we'll be able to assist you with all of this. But at the end of the day, we want to make sure that the end user or the customer or business owner has got the right solution installed for them. So by doing that, by making sure we make the right decision up front in the beginning, obviously saves you a lot of headache and hassle at the end of the day. With a residential unit or a residential site, obviously, yes, it is important to go and log and very important to know the customer's power requirements. When it comes to the C&I side of things, it is a whole different kettle of fish. So we need to make sure we do it right the first time, because comebacks and callbacks and redesigning a system once it's already installed becomes a lot more costly in a scenario like this. Next, we'll have a look at our static transfer switch, so STS, that comes with the ET50. So what is the STS? Why do we need it? And how is it beneficial to have it separate to a standard, normal hybrid inverter, where all of this would be built into the inverter itself? So there's two different things that we look at when it comes to the STS. Firstly, the STS is extremely compact and small. Secondly, there are no fans or anything built into it, so it is quiet, meaning we can install it inside a building and not have to worry about any noise or anything like that. Thirdly, this is where all of your AC transfers happen, or AC switchovers happen. You'll see at the bottom of the STS, there are 4 ports: an inverter port, backup port, generator port, and grid port. Meaning this is where your actual switching happens on the inverter or through the inverter on the AC side. So if we look at our backup port, it can change over and we can get power from the inverter, obviously the DC power that we're getting from the inverter, the PV and the batteries. Secondly, we can get power from the generator port. Thirdly, we can get power from the grid port, and all of that can run now into the backup port itself. So this is the switchover or transfer switch that we have with regards to the ET50. Why is it separate to the actual ET50 itself? 2 reasons. 1, longevity of a system outside of warranty. If we're looking at a system outside of warranty, within warranty, GoodWe does a full-on swap-out replacement policy, meaning if something goes wrong on a system, we swap the unit out with a new one. We do not book in the inverter for repairs or book in the STS for repairs, fix it and send it back to site. We swap the unit out with a replacement device. However, outside of warranty, obviously things are slightly different. Outside of warranty, we can book inverters in for repairs. We can book in the STS for repairs should something go wrong. But outside of warranty, if we're looking at year 10 or year 11 or year 12 on a system, where is something likely to damage or where is something likely to fault? If your system is installed soundly, you're doing routine maintenance, you know that your DC is installed correctly, your cables are connected correctly on your battery side, your panels are being routinely maintained, and your DC connections on the actual inverter and everything is fine. The only other logical explanation or logical place where something would go wrong would be on the AC switching side. And this is to no fault of any manufacturer. This is just the reality of it. Unfortunately, in the African market, we experience more power-related issues than in obviously the European market or Asian market. And the reason for this is because our transformers are not as stable as they used to be. And that will change. I'm hoping in the future, obviously, we'll have more stable power output. However, at the moment, we experience power outages. And when we experience power outages, switching needs to occur. Obviously, when switching occurs, we're using it through a contactor or a relay, and contactors and relays have a certain amount of lifespan. Meaning that if we're going to continuously, if we're looking at the STS now, we're going to continuously be swapping power around between grid port, generator port, and inverter port going into the backup load. Again, the inverter is meant to withstand this. The inverter is manufactured to withstand this. However, a contactor and a relay can fail over time. If we get into year 12 or year 13 on the project, it is a lot cheaper or a lot more cost effective to replace a section of the inverter, being the STS, as opposed to replacing the entire inverter itself. So by having it separate, 1, we are able to save money outside of warranty if we need to replace. And then secondly, and this is where it becomes the most vital or the biggest point with regards to why the STS is separate, is the fact that we can install this up to 100 meters away from our DC connection, or from 100 meters away from our inverter. So if we're looking at a site, for example, that is a filling station, so we'll use a filling station as an example because they generally have it already installed in this way. In the corner of the property, you'll have your main incomer, your utility incoming, and then you'll have your big diesel generator connected there. You'll have an ATS from there running into the main building, and you'll have one cable existing running into that main building. That cable that's running from your ATS or from where your generator and main income are coming in to your main building is generally a much bigger cable, and it is quite expensive to really run underground and. With a conventional hybrid inverter, how you would have to install it is you would then install your inverter in the main building because that's where you've got space to put your panels up, it's where you've got space to put your battery and everything. When you install it that way, you would need to retrench and run a completely new cable from your main incomer to your generator. From your main incomer to your inverter, from your generator to your inverter, and then obviously your backup loads need to be connected as well. One of the benefits of having the STS completely separate is we can now install that STS right there at the main incomer, close to your generator incoming, and you only have one cable link between your inverter and your generator and your STS. So that cable between your inverter and your STS is already existing on a plant like this, and you don't need to retrench or anything. All of your massive thick AC cable runs are going to be right next to each other because your ATS, your generator, and your main incomer are all in the one corner of the property already. You can install your STS there. The STS is IP60 rated or IP65, IP66 rated, meaning we can install this outdoors and we can install it right there where we need to, close to your generator, close to your main income in the corner of the building, and install your inverter itself with your DC at the main building. Where else can this be useful? If you're looking at a hospital or hotel environment, you'd install the inverter on the rooftop with the batteries on the roof as close to your DC as possible. And your main incomer might be in the basement of the building with the generator. You can run the STS in, put it in the generator room right at the bottom of the building, 100 meters away, 6 floors away, and you only have that one AC cable run. There's just a quick look at the STS itself, as well as the electrical cable information of the STS. Most of it is very similar to the actual inverter itself. Again, this is just the transfer or AC switching of the inverter. The physical AC relay on the backup output port is 200 amps, meaning we can put a total of 138 kilowatt pass through the backup port, meaning we can have additional contactors or something installed, meaning we don't have to necessarily split the DB board immediately. We could add additional contactors or something like that, meaning that when the grid is available, run the 438 kilowatts on your site, and if the grid does fall away, we can open those contactors, it will remove some of the load, and you'll go back down to the 50 or 55 kilowatts output that the inverter can allow in backup mode. This IP65 rated, has all of its IEC compliance regulations, as well as the inverter also having all of its NRS certifications and linked to the City of Cape Town's approved inverter list as well. So with regards to the generator port on the STS, we have two different ways we can use this generator port. On the inverter itself, we have two 5-amp dry contact relays. Those two dry contact relays we use for two things. One is for your generator's auto start-stop functionality, and two for a smart load control or a secondary AC output load control, big load mode, however you want to word it. It is essentially allowing us to have two different backup outputs and being able to control one of them. So if we look at the picture in scenario 1, we have got your generator connected to the generator port, and the blue dotted arrow going into the generator is the automatic start-stop functionality. Where it says big load, we've got a second dry contact relay running into a contactor, an external contactor, and that external contactor is allowing us to control a secondary output of load, meaning that we can have big load mode and backup loads, provided we don't exceed the 55 kilowatts. We can connect that in order. So where we could use this is in, for example, a packaging facility where we've got small packaging machines or something like that running as quote unquote big loads, and just the office lights, servo, printer, that kind of thing running as your standard backup loads. So when my batteries are full or during peak production times, allow both big load and backup loads to be open. When my batteries reach 40%, disconnect or open that relay and disconnect my big loads, meaning that the physical production will stop. However, I'll still have full access to my normal office equipment. If we go to scenario number 2 on the right-hand side, it does work in the same way. However, we are using the physical generator port as the secondary AC output. So the generator port is dual purposed. The generator port can be used either for one generator integration or 2 secondary AC output that is configurable. Next, we'll have a look at parallel solutions. So we have 2 different ways that we can parallel the system. The first way that we parallel a system is using our EasyLink 3000 communication dongle. The EasyLink 3000 communication dongle is the cost-effective alternative to paralleling a system, and this is where we recommend no more than 2 inverters. Yes, we can parallel up to 4 of them using this solution. However, when it comes to a CNR space, we want to look for as stable a solution as possible, and that's where we'll talk about the SEC3000C controller next. So on the left-hand side, we've got our EasyLink 3000 controller or communication dongle. This is a physical communication dongle, no bigger than the standard Wi-Fi LAN kit communication dongle you would get with the inverters by default. All of your inverters are connected via parallel CAN communication, and your master inverter has got your smart meter and CTs connected with its own set of PV and batteries connected to each inverter. This is standard parallel communication method that we use for GoodWe on our residential units as well as the ET50. Again, we can parallel up to 4 of these units like this. However, our recommendation due to stability purposes and just making sure that everything does work as best as possible, we recommend no more than 2 of these units in parallel. Why we recommend no more than 2? Again, like I mentioned, this is for additional stability because of the amount of data that needs to transfer, because of the 4 millisecond transfer time that we can ensure, because of unbalanced outputs or unbalanced loads possibly, and that kind of thing. It does make the system a lot more stable if we're doing it through a full-on controller rather than the communication dongle, which does work for 2 units. 2 units, the communication is a lot quicker. There's only 2 of them, and everything does work as it is expected to. If we look on the right-hand side, this is our SEC3000C controller. So the SEC3000C controller is an all-in-one controller that allows us to do a lot more. This is essentially the master controller. Every single inverter gets individually connected to the system. And then we still have parallel communication cables between every single inverter itself as well. You'll see the smart meter and CT is also connected to the SEC3000C controller by default, and everything else runs through that controller as well. With additional redundancy and everything that comes with the controller, what is nice about this, again, if we lose any inverter for any reason, the rest of the system can continue to operate. All of the inverters are connected independently into the controller, so all of them can be independently controlled, monitored, and obviously then set up as well. Another thing about our SEC3000C controller is that we can add additional grid-tied inverters onto a system. So if you have a massive plant, we've got an example of one of these where we've got a 1.2 megawatt grid-tied system running their main factory, and they've got 400 kilowatts of backup running one of their smaller factories on the same premises. We have got everything connected to this one SEC3000C controller, meaning that wherever we clamp on our CT side, the PV from both departments or both sections, grid-tied and non-grid-tied hybrids, can be joined together, and that power can be distributed evenly across all of them. So when we do this using the SEC3000C controller, we can parallel up to 60 grid-tied inverters, and then up to 10 hybrid inverters in parallel as well. There's a few other benefits of using the SEC3000C controller. One of them, for the city of Cape Town specifically, we had a case not too long ago where they need to have full control of your system remotely to be able to shut down the system or control the power flow through the inverters itself, because they are allowed to export back to the city. In the past, you would need to use a third-party logger or third-party controller that has got IEC 104 protocol compatibility. The SEC3000C controller has got IEC 104 protocol compatibility built into it, meaning that we don't need to use any additional controller. One of the other benefits to this is we have got third-party control or third-party compatibility with other controllers using our controller as well, or other energy meters like the Unitsa control energy meters, or any other Schneider meter or anything like that. We can use these as well. There's a specific Unitsa meter that we can use that clamps onto a bigger incoming line rather than a standard 5 amp secondary ratio CT or standard CT connection. We can use a Unitsa meter. That Unitsa meter is completely compatible with our SEC, meaning that we can use that, not having to use any step-down converter or anything from the 11 kV or 44 kV CT connection on a Unitsa going down into the SEC controller. It adds additional accuracy to make things a lot better for our systems. Battery compatibility. So we have got two different ways that we do battery compatibility with regards to GoodWe. One of them being our Type A battery compatibility list, and the second one being our Type C battery compatibility list. Our Type A battery compatibility list are our international batteries that are compatible. Our Type C list are the local batteries that are compatible that use our default protocol. So we have two different ways we do battery compatibility. On the Type A international list means GoodWe take an inverter, they give it to BYD, BYD take a battery, they give it to GoodWe, and we cross-match the protocol from both sides or both R&D teams to allow the protocol to be 100% matched. The second way we do battery compatibility is our local way, and with the local batteries like Lithium Battery South Africa, for example, LBSA, what we did there was we took an inverter, we gave it to the team at LBSA, we gave them our default high voltage battery protocol and said, this is our inverter, this is the protocol, and their R&D team matched their battery firmware and battery protocol to match the GoodWe default protocol. The only thing that changes from a commissioning standpoint is when you commission the inverter for the BYD, that is a list A, we can select BYD Max Light and the battery itself. When we're connecting to a LBSA battery, for example, we will connect to GoodWe default HV battery. From a warranty standpoint, it makes no difference. The warranty will be upheld regardless of which battery is connected from the Type A list or Type C list, provided it is compatible. We have got an official battery compatibility statement available on our website. I'm not sure if the page will open up and display. However, if you click on the bottom there, we'll have a look in our website. you'll be able to get a full list of batteries that are compatible, and that full list of batteries that are compatible will show us things like our low voltage batteries as well as our high voltage batteries that are compatible, all the way across every inverter or every inverter series, from our ET5 kilowatt inverter all the way up to the ET100 kilowatt inverter, for example, or our smaller single phase batteries, single phase inverters as well. And that will give us a full list, a full breakdown of batteries that are compatible. The picture that you're seeing now is just a quick look at the batteries that are compatible, but not necessarily all of them. So that's it for the inverter side of things. I'm just going to go through the two battery pairings that would go with the ET50 inverter from a GoodWe standpoint, the BAT 100 kilowatt hour battery and the BAT 56 kilowatt hour battery. So this is the BAT 102.4 kilowatt hour battery or outdoor battery rack. This is a all-in-one battery cabinet. This all-in-one battery cabinet weighs just over 1.3 tons. I think it's about 1.4, 1.5 tons. And it comes with everything already included, already built in, as well as an additional or external air conditioning unit on the back. So this is an all-in-one cabinet that we can use for our battery rack. The inverter gets mounted on the side of it, and your STS obviously gets mounted closer to your main incomer. However, this is what the battery rack would look like. It comes pre-built already from factory. The only thing you need to wire in are your DC cables going to your battery, to your inverter itself, and the AC cabling from your smoke detectors and emergency stop into the system itself as well. So on the back end of this cabinet has got an air conditioning unit that we can regulate the temperature for it. On the top, M16 rings to be able to carry it in by crane. At the bottom, next to the wireways, we have got two different forklift variation options. So either the standard forklift, or if you're coming in from the side, narrow-armed forklift as well. But please do note that this battery does come already pre-installed as you see it here. Only the DC and AC cables need to be connected on the actual PDU or power distribution unit at the bottom. These batteries, we can connect up to 4 of them per inverter, meaning we can go with a 50 kilowatt inverter and 400 kilowatt hours of battery, and up to a maximum of 500 kilowatts and 4 megawatt hours of battery connected onto one system or plant. This is just a quick look at the battery itself. It has got 10 packs of 10 different modules. If we go back, you'll count there are 10 modules. Every module is a total of 10.24 kilowatt hours, with a usable energy in total of 100 kilowatt hours. This is not scalable inside the same cabinet, as this cabinet does get pre-manufactured and pre-assembled at our factory. It is a 0.9C charge and 1.1C discharge battery, which isn't an issue at all. We obviously get the maximum out of this battery permanently because we'll connect this to our 50 kilowatt inverter. This battery is also compatible with our 100 kilowatt ET series inverter, which is why we've got the 1C, well, 0.9C and 1.1C charge and discharge. The depth of discharge is 100%. Again, we have this conversation relatively often. Should we be discharging our batteries down to 100%? In my opinion, no. I don't think it is obviously very good for a battery to run down to complete 0% all the time. We want to keep some form of a buffer on the bottom end of the cells, just so that if the power is out for an extended period of time and we can't recharge the batteries, at least there is a little bit more power available for us to be able to keep the battery alive and keep everything working as it is intended to. Between 85 and 90% usage of the battery is where I feel it would be a lot better, and obviously be able to use the battery fully. Yes, there is a built-in air conditioning unit on the back. It is IP55 rated due to the air ventilation and that we have on the back end of the unit, where we have got the air conditioning unit as well. So this is just a full solution, what we could see. So the BAT 102.4 battery system is paired with our hybrid inverter, which is our ET50. to form a compact storage solution. When we pair it with the STS itself, is where we would be able to achieve UPS level switching to be able to interact with on-grid and off-grid, and then connect our diesel generator if we need to connect a generator as well. The next battery pairing that we have from a GoodWe standpoint is the BAT50 6.3 or our BAT56 battery rack, which is a flat-packed rack-mounted battery. This battery comes flat-packed in a box. Every module comes in its own box, as well as the PDU. All the battery connections are also all included in the box, as well as the communication cable and terminating cables as well, or terminators for the comms cables as well. That all does get included. So we just need to physically plug and play with this battery. However, the battery does come flat packed, which makes it easier for mobility, makes it easier for your actual installation to get it to site. However, obviously it does depend on the site itself. These batteries, we can connect up to 6 of them in parallel. So we can connect 6 batteries onto one ET50. It is 56 or 55 kilowatts of usable energy. So at 55 kilowatts of usable energy times 6 is 330 kilowatt hours per inverter. And we do that times 10, it's 3.3 megawatt hours as a total. So we can go 500 kilowatts and 3.3 megawatt hours as a maximum on the system using this battery configuration. The physical pack level is half the size of the previous BAT100, so it's 5.12 kilowatt hours per rack as opposed to 10.24, with each pack itself or each module itself weighing just over 42 kgs, meaning that it is possible for 2 people to install the system, to install the battery rack themselves, unless you are strong enough, obviously, to lift 42 kgs to shoulder height, then you can obviously do this alone. There are 11 packs in the total solution. We can lessen the packs down to 10. When we lessen the packs down to 10, we get a usable energy of 50 kilowatt hours. And that is more to go with our 40 kilowatt unit as opposed to the 50 kilowatt inverter. Same thing with regards to the charge and discharge rates. There's a 1.1C charge and discharge. So we'll get that maximum 100 amp charge and discharge on the ET50 using this battery. This battery and the previous battery that we mentioned, both of them have got black start functionality, meaning that we can black start the system, start the inverters up using just the batteries and get an output. We don't need PV, we don't need the grid in order to start the system up, start the batteries up. There's no AC power requirement from the batteries as well. They can power up and output from just DC power. There is no AC power connection required in order to keep the PDU alive or keep it connected. We don't need a UPS to keep it working or anything like that. We just connect the batteries together, turn the battery on, and off we go. Round trip efficiency of 96% at 100% depth of discharge. Normal parallel or normal CAN communication between all of our batteries. And all of our batteries obviously do conform to the IEC safety regulations. This is an RP20 rated battery, meaning that we do need to install this indoors as well. So please just do bear that in mind when we are purchasing these batteries. Just want to confirm and check if there are any questions before I move on. Okay. Lastly, we will do a case study video that we have for a system that we installed. This is a very big system that we installed in Johannesburg. We have 10 of these inverters connected in parallel using an SEC 3000C controller. And this SEC 3000C controller obviously controls our entire system. We've got 20 of these batteries, 20 of the BAT56 batteries connected in parallel on the system. And the installation is probably one of the best installations I've ever seen. So extremely, extremely proud to have the GoodWe name a part of this. We have got one of the installers actually in the presentation today. It was very nice to see him joining us. So thank you very much for being here, as well as obviously then Plexus, the main installer company that did the installation itself, or that did the build itself. So I'm very, very happy to show you this video. This is on one of our biggest systems. This system, the main application for it was they have got a massive inductive load startup on the site. They also have got a very high electricity bill. So they're using the ET50 for peak shaving. They're not using the ET50 for full backup scenario. They're using the batteries and the system to get as much as they can out of the DC power that they can generate. And by doing this, obviously cut down on their electrical bill. They partnered with Longi on the panel side, and the panels are extremely, extremely incredible. But let's have a look at the video, and from there we will take it a bit further.
Support is amazing. Been an absolute pleasure doing business with GoodWe.
I'm here with Francois from Plexus, visiting a recently commissioned commercial storage project.
Well, the reason why we prefer GoodWe is just, you know, the support is amazing, and fundamentally that's what we need. So we've got 10 GoodWe ET50 hybrid inverters with each of its own static transfer switch at the bottom. We've then got just over 1.1 megawatts worth of battery capacity deployed on the one site on the left. And then with just under a megawatt worth of PV production coming from the top. We specifically designed the project around the Longi Extend 645 watt battery. Jaco, and I must say your team was brilliant, phenomenal from the start. It's been an absolute pleasure doing business with GoodWe, and I think that's why we've become a GoodWe house altogether. We won't touch anything else purely because of the service, the backup, and when something does go wrong, your guys and your team is right there with us every step of the way. So thank you, and I hope we can continue this great relationship going forward.
Thank you, Francois. Thanks a lot for your time. I'm really looking forward to the next site visit and to work on the upcoming projects with you.
We'll be happy to host you, Jaco. Thank you very much.
That is it for our presentation today. Like I said, the installation that we just witnessed there, obviously what we look at is, like I said, probably one of the best, if not the best installations that I've seen with regards to the ET50 installations, or is the best installation I've seen with regards to the ET50 installations. And we're incredibly proud to be partners with Plexus and the installers that ran with the site itself. And we know that there are more sites coming up like that, and we're hoping to see a few more from the guys that have joined our presentation today. So thank you very much to everybody that joined. If we do have any other questions, please do feel free to reach out to myself, reach out to Linda, obviously from our marketing team, or reach out to our sales department, and we'll be able to assist you in any way that you may need it. Thank you very much to everybody that joined. I hope you have a really good Thursday further. Not trying to wish the weekend away or weekend here, but let's hope that Friday comes a bit sooner than we hope. Enjoy the rest of the day, everybody. Have a good one. Cheers.